Hi, I am Georgios Papadopoulos and welcome to this video on Carrier Sense Multiple Access CSMA Medium Access Control MAC Protocol. So far, you have seen the Aloha protocol where whenever a transmitting node has a frame to transmit, it simply does so without following any other rule. Today, I will introduce you to an advanced random access protocol called CSMA, which is based on the principle sense before transmit or listen before talk. In this video, we are going to start first with the CSMA overview, then we will continue with the collision scenarios in CSMA. Next, we will cover the vulnerable time, and finally, we will conclude by presenting the three persistent methods in CSMA. Let us now start with the overview of the CSMA MAC protocol. To minimize the probability of collision and therefore to improve the overall performance of the network, the CSMA method was developed. The chance of collision can be reduced if a node sends the shared transmission medium before initiating a transmission.
Let's assume that the time is continuous and that our communication medium is the air in this example. Unlike the Aloha-based protocols, under CSMA, a transmitting node uses a carrier sense mechanism to sense the shared transmission medium to determine if it is in idle or in busy state. In other words, it tries to detect the presence of a carrier signal from another node before attempting to transmit its own frame. If a carrier is sensed, which means that the shared transmission medium is busy, thus the node waits for the transmission in progress to end before initiating its own transmission. When the shared channel becomes idle, the node starts its own frame transmission. By employing CSMA, multiple nodes may in turn send and receive frames on the same shared medium.
Note that the transmissions by one node are generally received by all other nodes connected to the shared medium and are within the radio propagation of the transmitter. To summarize, under CSMA MAC protocol, unlike Aloha, whenever a node has a frame to transmit, it will listen first to the shared transmission medium before transmitting it. Next, by minimizing the probability of collision, CSMA essentially increases the performance of a network when it is compared against Aloha protocols. Variations of CSMA include addition of collision avoidance, CSMA CA, and collision detection, CSMA CD techniques. As we previously saw, CSMA can reduce the possibility of collision by sensing the shared transmission medium to detect the presence of a carrier signal before transmitting a frame. However, CSMA cannot eliminate the collisions. Indeed, there are scenarios where the transmissions of two nodes may collide even though the two nodes perform the carrier sense mechanism before transmitting their frames. Let us now see a few scenarios to understand why there might be a collision in CSMA. The first scenario is related with the simultaneous carrier sensing. For example, two nodes perform the carrier sense mechanism and detect that the shared channel is idle at the same time, and therefore they both start frame transmission simultaneously. As a result, there might be a collision. Next, we have the hidden node problem scenario.
Let's assume that there are three nodes, A, B, and C, and each node comes with a propagation range that allows them to communicate only with their direct neighbors. More specifically, node A can communicate only with node B. Node C can also communicate only with node B, while node B may communicate both with nodes A and C. However, nodes A and C cannot communicate with each other as they are out of range. These nodes A and C are known as hidden nodes. The problem is when nodes A and C not necessarily at the same time perform the carrier sense mechanism to detect that the shared channel is idle and start to transmit frames to the common destination, node B. Because the nodes A and C cannot receive each other's signals, thus they cannot detect the collision before or while transmitting, collisions will occur. As a result, the node B receives corrupted frames.
The last scenario is related with the propagation delay. Indeed, when a node transmits a frame, it still takes time, although very short, for the first bit to reach every node within the radio propagation and every node to sense it. In other words, a node may sense the medium and find it idle only because the first bit sent by another node has not yet been received.
Let's consider a network that consists of 4 nodes A, B, C, and D. Then let's assume that at time t1 node B senses the shared medium and detects it idle, so it can transmit a frame. Then at time t2, where t2 larger than t1, node C senses the shared medium and detects it idle, thus it also transmits a frame. Why? Because at this time the first bits from node B have not reached node C, thus node C also sends a frame. As a result, the two signals collide and consequently both frames are destroyed.
Let us now have a look on the vulnerable time in CSMA. Now, the length of time in which there is a possibility of collision is defined as the vulnerable time.
Considering again the previous network example that consists of 4 nodes A, B, C, and D, now the amount of time that it takes for the head of the signal to propagate from one end of the shared medium to the other is called the propagation time. In this example, when node A transmits a frame, and if any other node tries to send a frame during this time, then as we previously saw, the two signals will collide and consequently a collision will result. But when the first bit of the frame reaches the end of the shared medium, which is equal to propagation time, every node will already have heard the bit based on the carrier sense mechanism of CSMA and will refrain from transmitting their own frame. Therefore, in CSMA, this gray area, which is equal to the propagation time, is actually the vulnerable area in time and space. More specifically, the leftmost node A transmits a frame at time t1, which reaches the rightmost node D at t1 plus propagation time, which is equal to the vulnerable time. To conclude, the vulnerable time for CSMA is the propagation time Tp.
The last part of this video is on the persistent methods in CSMA. So far, we have seen an overview of the CSMA MAC Protocol, the potential collision scenarios, and the vulnerable time in CSMA. In the following, we are going to talk about what should a node do if the shared transmission medium is busy or idle. To answer this question, 3 methods have been defined: the one persistent, the non-persistent, and the p-persistent method. Let's start with the one persistent CSMA method. One persistent CSMA is an aggressive transmission algorithm.
Under one persistent method, when the transmitting node has a frame to transmit, it continuously senses the shared transmission medium, in other words, the shared channel, to check its state. More specifically, it checks if the medium is idle or busy. If the shared transmission medium is idle, the node A transmits its frame immediately. However, if the shared transmission medium is busy, then the node will continue sensing the shared medium until it becomes idle. Once the shared medium is idle, the node transmits its frame immediately with probability 1. In fact, due to probability 1, it is called one persistent CSMA. In case of a collision, the transmitter must wait for a random amount of time and start the same procedure all over again. To summarize, here is the flow diagram for one persistent CSMA method. The transmitting node continuously senses the shared transmission medium. If it is idle, it transmits immediately the frame. Else it continues to listen until medium becomes idle and then transmits immediately. One persistent CSMA has the highest chances of collision because two or more nodes may find the shared transmission medium idle and transmit their frames immediately. Last but not least, one persistent CSMA is used in CSMA CD systems, including Ethernet.
Next, we have the non-persistent CSMA method.
Under non-persistent method, when the transmitting node has a frame to transmit, it senses the shared transmission medium to check if it is in idle or busy state. If the shared medium is idle, the node transmits its frame immediately. However, if the shared channel is busy, it waits a random amount of time and repeats the whole logic cycle again. To summarize, here is the flow diagram for non-persistent CSMA method. The transmitting node senses the shared transmission medium. If it is idle, it transmits the frame. Else, it waits a random time and starts the same procedure again. The non-persistent approach reduces the chance of collision. Indeed, there is lower probability that two or more nodes will wait the same random amount of time and retry to transmit simultaneously. However, this approach reduces the efficiency of the network because the shared medium remains idle when there may be nodes with frames to transmit.
The third and the final method is the p-persistent CSMA.
The p-persistent method is employed if the continuous time of the shared channel is divided into discrete time intervals called slots. Each slot duration is equal to or greater than the maximum propagation time. Under p-persistent method, when the transmitting node has a frame to transmit, like one persistent, it continuously senses the shared transmission medium for idle or busy state. In this method, once the node detects the shared medium idle, it continues with the following steps. With probability p, the node transmits its frame. Let's assume that in this case the probability outcome was p, thus the node A transmits its frame. While with probability 1 minus p, the node waits for the beginning of the next time slot and checks the shared transmission medium again. Let's assume that in this case the probability outcome was 1 minus p, thus the node A does not transmit its frame and it waits until the beginning of the next available time slot, which is the slot 3 in this example. In the following time slot, slot 3, if the shared transmission medium is detected idle, it will go back to step 1. However, if the shared transmission medium is detected busy, the node will continue as though a collision has occurred and thus the back-off procedure will take place. To summarize, here is the flow diagram for p-persistent CSMA method. The transmitting node continuously senses the shared transmission medium. If it is idle, it transmits with the probability p and delays for a time slot with probability 1 minus p. In the following slot, if the medium is idle, repeats the whole logic cycle again. If it is busy, uses back-off process. The p-persistent CSMA approach combines the advantages of the one-persistent and non-persistent CSMA access modes. Indeed, it reduces the chance of collision and improves the efficiency of the network. Finally, p-persistent CSMA is used in CSMA CA systems including Wi-Fi.